So instead of using theta, we have t here. You could just write it also as theta equals pi over 4. And what we have is we have a unit circle. What do you think is the radius of the unit circle? 1 unit. So the distance from here to here is 1. By definition, the unit circle is a circle with a radius of 1. That's just what we're going to use, okay? So it has an equation of x squared plus y squared is equal to 1. That's the equation for the unit circle. So I'm looking for a terminal point or a coordinate on the unit circle. If I put my pen right here and make a dot, can somebody tell me what the coordinate is right there? What is that coordinate on the xy axis? What is the x value? How far over am I? 1, 0. Good. Let's try another one. What is the coordinate right there? 0, 1. What is the coordinate right here? -1, 0. What is the coordinate right here? 0, -1. Any questions on how I got any of those 4 coordinates? Okay, so what we want to do is we want to figure out yes, but we will never use 2, but always use the unit circle. You'll see why in a second. Okay? Here's what this question is asking. Suppose theta is pi over 4. From yesterday, do you remember how many degrees is pi over 4? What's 180? Pi. So what's 90? Pi over 2. 45 is pi over 4. So what I do is I take pi over 4. So this might be what you have to do in your assignment. If you don't remember, pi over 4, and we multiply it by 180 divided by pi. What happens to the pi's? They disappear. And 180 divided by 4 is 45 degrees. So I'm going to use 45 degrees. Okay? So what this is asking is for a theta value of 45 degrees, what is the location of the terminal point? Meaning, what is that x, y value? That's what we want to figure out. So we're going to use our knowledge about special right triangles. This is 45 degrees. Everybody agreed? I'm going to make a 90-degree angle. If this is 45 degrees, what's the other angle? 45 degrees. What special right triangle do I have? 45, 45, 90. Everybody okay with that? All right. Here's the part you really have to focus with me on. If I'm in the unit circle, that means that the radius is always 1. So what is this distance of this blue segment here? 1. So the hypotenuse has a length of 1. Do you remember what we did to go from the shorter side to the longer side? We multiplied by the square root of 2. Well, now I have the longer side. how do I go from the hypotenuse to the shorter side? Instead of multiplying by the square root of 2, I will divide by the square root of 2. Am I allowed to have a square root in the denominator? So what do I have to multiply the top and bottom by? Square root of 2. And we get square root of 2 over 2. Square root of 2 over 2. Because the square root of 2 times the square root of 2 is square root of 4, which is 2. Now, what else do you know about 45, 45, 90? So that's square root of 2 over 2 as well. So, we now have enough information to determine the location of the terminal point. The x value refers to how far over I go to get to that spot. What is this distance right here? Square root of 2 over 2. What is this distance right here? Square root of 2 over 2. So what that means is if I have a theta value of pi over 4, it has a terminal point of root of 2 over 2 and root of 2 over 2. Okay? Kind of tricky, huh? We need to see another example. So let's do another example. We'll multiply by 180, divide by pi. Does anybody remember what 4 pi over 3 is? We'll cancel off the pi's. 180 divided by 3 is 60, times 4 is 240. Which quadrant will 240 degrees place me in? That will be in the third quadrant, won't it? How many degrees past 180 will it be? 60 degrees past 180. So the angle starts here, I go all the way around to here. 240 degrees. Now, you guys all told me that how many degrees past 180 did I go? 60. So I'm able to make a special triangle. I know that this is 90 and that is 60. So what is this one right here? 30. I've made my special triangle. And you guys see how I drew the height? I drew it to the x-axis. You'll always draw it to the x-axis. Don't draw it to the y. Always draw it to the x-axis. Okay? So I have a 30, 60, 90. What is always the distance from the center to the circle in the unit circle? Which is the shorter side? The green side or the red side? How do you know the red one's shorter? It looks like it. What if you didn't draw it very well? It's across from the 30-degree angle, so that's the smaller one. So, how do you get the smaller side if you know the long side is 1? Remember? It is 1/2. Look at what we have here. If the hypotenuse is 10, the shorter side is 5. If the hypotenuse is 12, the shorter side is 6. So we take the hypotenuse and we divide it by 2. So therefore, as you look at this picture, we know that this red length is 1/2. 0.5, we will write it in, as a fraction. We'll stay away from decimals for quite a while. Can you tell me, what do I do to get the longer side then? Multiply by square root of 3. And when you take the square root of 3 over 1 times 1 half, you get the square root of 3 over 2. That's how we write it in simplest radical form as a fraction. So we have square root of 3 over 2. Again, the whole question was, what is the terminal point that is determined by the angle 4 pi over 3, or 240 degrees? What is that x value and y value? So the x value is the horizontal value, and it is 1/2, but because it's in the left direction, it's negative. And then what is your y value? Square root of 3 over 2, and is that positive or negative? Why? It's down. So that's what we get. Try 2 more. This one's like the other 2, and this last one's really easy. What do you notice about this? It's negative, okay? So we'll multiply again by 180 divided by pi. What happens to the pi's? They cancel. And then 180 divided by 6 is 30, times 5 is 150. We have negative 150 degrees. So I always start here at 0. And then what do you think it means to have negative degrees? Yeah, instead of going this positive way, we go a negative way. Well, so it's not quite all the way to this spot, is it? How much would this be? Negative 180. So how many degrees short of 180 am I? 30 degrees short of 180. So you can see that that's a 30-degree angle there. I will make a triangle with the x-axis. So what kind of special triangle do I have? A 30, 60, 90. My objective is to determine the location of the terminal point. What is this distance right here in the unit circle all the time? 1. Which is the shorter side, the vertical side or the horizontal side? The vertical side, right? That's the shorter side. So what do I do to get the vertical side, the shorter side? Divide it by 2 to get a half. What do I do to that to get the horizontal side, or the longer side? If it's a 30, 60, 90, use the square root of 3. If it's a 45, 45, 90, it's a square root of 2. Yep, just from like what we laid out here, you can see this involves the square root of 3. This involves the square root of 2. It really isn't. No, I just want to show it up there so you can see it twice. Okay? Just want to see it twice. Okay, alright, our goal is to find this coordinate. It's an x, y coordinate. So x is the horizontal distance. What's the horizontal distance? And is it positive or negative? Negative for the 3 or 2. What's the vertical distance? It's a negative, so negative 1 over 2. And that's my location. That's the location of that coordinate. Okay? Ready for an easy one? Okay. Before I show you the easy one, do you notice any similarities between problem C and B? Yeah. In fact, in these problems, you're always going to come up with these values. Square root of 2 over 2 and square root of 2 over 2 would be positive, negative. Or 1 half and root of 3 over 2. Or root of 3 over 2 and 1 half. Positive, negative. They'll always end up being one of these examples. Always. Except for our very last one. Right. Our very last one, pi over 2. Does anybody remember what pi over 2 is? 90. So this is negative 90 degrees. I didn't even do the conversion because I'm so smart I remember. Okay, we'll practice tomorrow. Negative 90 degrees. So where will that bring me? Yep, straight down right here, right? Now, inevitably, all people, when they get to the spot, they want to make a triangle. Don't make a triangle. Don't. You're like, well, why not? Our goal is to determine the point, correct? Look at this. Didn't we already determine the point of all those axes? Like if you fall on the x-axis or y-axis, we already know the point, don't we? What's this coordinate right here? 0, negative 1. Easy peasy, lemon squeezy. Done. See how nice that was? So, you will always come up, and it could be positive or negative, you will come up with these values. 0 or 1 half or root of 2 over 2 or root of 3 over 2 or 1. Those are all the values that you generate. You just have to determine which set by making your right triangle. Now, Emma, you've seen this before and rather recently, right? Is there anything I missed out? Okay. Because I want you to know that this isn't easy to get used to. We're going to spend some good time practicing, okay? So, I'll hand out the assignment. We'll help you get started. We'll do the first problem. You make fun of my circle. Okay, it says pi over 6. What is that in degrees? Do you remember? Multiply by 180 and divide by pi. We get 30 degrees. So I have a 30-degree triangle. A 30-degree angle. What should I do next? Make a triangle by drawing it. Do I draw it to the y-axis or to the x-axis? Always to the x-axis. Make 90 degrees. What kind of special triangle do I have? A 30, 60, 90. We don't know any of the sides. But fortunately, we decided we're working in a unit circle. This point was 1, 0, and this point is 0, 1. So what is the length of the hypotenuse of that triangle? Always 1. What's the easier one to find now? The longer side or the shorter side? Shorter side, I divide it by, and I get 1 half. What do I do to the 1 half to get the larger side? Multiply by the root of 3, I get the root of 3 over 2. So our goal was to determine the location of that xy coordinate. What is the x value? What is the y value? Does it get better? Okay, let's try another one. Let's flip it over. How about we try problem 14? I got 7 pi over 4. Uh-oh. Multiply by 180, divide by pi. Pi's cancel. 180 divided by 4, 45. So I've got 7 of the 45s. If you do that on a calculator, you get 315 degrees. Which quadrant does that put me in? The 4th quadrant. So if that's 315 degrees, and this is 360, how many degrees are left over here? 45. So this angle is 45 degrees. So what kind of special triangle do I have? 45, 45, 90. I have to figure out the location of the terminal point. Oh no, I don't have any lengths. 1! Hey, I remember 45, 45, 90s have something to do with the square root of 2. So do I multiply by the root of 2 or divide by the root of 2? Divide by the root of 2. So I have 1 over the root of 2. Oh no, my algebra 2 teacher told me I can't have a root of 2 in the denominator. Oh yeah, multiply it by the root of 2. I get the root of 2 over 2. Oh, I don't want to have to do that again. That took forever. Oh, it's the same because it's a 45, 45, 90. Hey, I know the location. What's the x value? Positive root of 2 over 2. What's the y value? Negative root of 2 over 2. Should we do one more? 16? Should we do 16? All right, we'll do 16. Two pi. How many degrees? 360. Right? So it's right there, right? Like it starts here and I go all the way around to that same spot, right? Yeah, there you go. So it's just we don't have to make a triangle. It ends up on the x and y axis, so it's just 1, 0. That was easy. Right? No triangle needed. If it ends up on the x or y axis, no triangle needed. It's only if we don't end up on the x, y axis, we got to make a special triangle. We will do a checkpoint on a small. Folks, if you are not one to bring homework home with you, tonight is the night you want to bring it home. And if you don't understand what you're doing, watch the lesson again. Trust me, you want to figure this out. This is crucial. You learning this means success moving forward. Trust me. Because you're going to have to do the same thing again. You have to do the whole worksheet again. Except you're going to be figuring out sine, cosine, tangent, secant, cosecant, and cosecant. If you can't do this one, you won't be able to do the next one. So learn how to do this one.